Okay, now in this part we're dealing with some population information and we want to talk about some population projections and population growth rates. So keep in mind that our exponential function goes a equals a naught e to the kt power. So we have some numbers for k, for t, for a naught, depending on what we're doing here. Let's work first with the 2010 population. That's where we're going to start our record keeping from. So that's going to be the initial amount a naught. The projected population is going to be amount in the future, and that's what the letter A is going to stand for. The growth rate is our letter K. So these are kind of going to be where the numbers are going to be going. We're going to start out with this Germany situation here. We have a 2010 population, a projected 2050 population. So what does that mean for the growth rate of Germany? So let's plug our numbers in. If I plug in the number 70.5 for A, that's going to equal to 82.3 e to the kt power. We do know the number of years here. Time t is 40 years, since we're dealing with 2010 to 2050. So we'd have 40k up on top. So now we have the numbers plugged in for a naught, and t. What we're going to do now is we're going to solve for k up on top. The way I'll do that is I'll divide both sides by 82.3. So if I divide those 70.5 divided by 82.3, I got out approximately 0.8603. That's equal to e raised to the 40k. Now if I take the natural log and put that on both sides, and so we have ln of 0.8603, and again ln is log base e, so that's going to cancel out with e here. And so we're going to just have 40k equals ln of 0.8603. We can divide out 40 from both sides. And so now we're going to have k is equal to all this stuff over here. Okay, and so if I approximate this with the calculator, it's going to give me the approximated growth rate. And I'm going to have a fairly small number here. I rounded it off to 0.00387. So I guess more or less we could say this is, rather than a growth rate, this is now a decay rate, since the population is declining and we have a negative number for k. Okay, so now we put that information in our table, and let's look at the Philippines down here. Again, using the time frame of 40 years that we have here, we're going to use the growth rate and the 2010 population to calculate the future 2050 population. So our a equals a naught e to the kt. Let's plug the numbers in that we have. For a naught we have 99.9, e raised to the 0.0095 times time, which is 40 years. So in a case like this, we've just plugged all the numbers straight in that we needed to, and we can just plug that in straight to the calculator and get an approximation. I rounded it off to 146.08, which in this case is dealing with the population in millions.